Hi, I'm Tim Sibiski. I'm a QA automation engineer, and this is Food for Thought from Mindgrub. And the topic of today is the role of QA automation in the software development lifecycle. So, the first point I want to point out is the difficulty of quantifying the impact of automation engineers. It's not exactly easy to see the output beyond the code that you get. It can be harder to sell the impact that an automation engineer has to people who aren't directly part of your team. And even within the team, it can be hard to see how automation is positively or negatively impacting your software development lifecycle. And the reason for that is when things go right, the developers and to an extent QA get recognition for that. When things go wrong and they get caught before they go out, QA, manual QA, generally is going to be seen as the ones that caught those issues. If your automation engineer is also the one writing out bugs, then you'll start to see something from there. You may assume that the automation engineer wrote that ticket, found the bug via automation. But because of that nature, it's not exactly clear to everybody, and it's not easy to quantify their impact. So it's best viewed as an upward trend in quality. Once you start implementing automation, you get things working, you'll have an exponential increase in the quality of your software as it goes out. You'll have less bugs. And once you see that trend, it may take a little while. It might be return on investment that takes a while to build up, but once you start to notice it, you're going to notice it even much more quickly. So it will never replace manual testers. If you try to replace manual testers with automation, you're going to have a bad time. The reason for that is down here. But essentially, automation is going to cover repetitive and simple tests that you write. Anything that can be very time consuming, that is monotonous for a tester will, they're human, start to zone out if they've done the same thing over and over again. And when you take that repetitive and simple testing away from them, it allows them to have a fresh set of eyes and to do much more complex and exploratory testing. And those are the tests that are going to catch the really critical issues. So you are freeing the manual testers to spread their wings and really use their talents. What makes them a good manual tester is what's going to shine through when you free them from these repetitive tasks. Once you have those all covered and you're comfortable with your framework and the quality of the framework, then it's a good idea to move onto the complex and time-consuming tests afterwards. And then the final point is the scalability of testing is going to be critical in deciding if you need automation engineers. If your application is going to be growing continually, then you are going to want to have automation. It's going to be more and more work for a manual tester every release that you have for an application, because they have to go back and test essentially everything. And when there's a new feature every iteration, they're testing more every iteration. So when you free them up from those repetitive and simple things, and even some of the complex and time-consuming things, you're saving them a lot of time. You're not having this exponential increase in testing effort, and you're not going to have to hire more and more manual testers every iteration to keep up. So that's critical. So let's go on a little automation journey deeper into this. And we're here. What a journey that was. No refunds. Okay. Layers of defense against a buggy release. The first layer is unit tests, which are going to be very fast. Second layer is API tests. They're pretty fast as well. Third layer is automation, which is going to be slower. And then the fourth layer is manual testers, which is going to be very slow. So unit tests are going to be the first thing that your developers write once they've completed code, or preferably before they even write the code out if you're doing test-driven development. And that's going to be very fast. It's going to catch a lot of very basic, important logic issues. Almost everybody does this. The next layer is API tests. Not a lot of people do this, but it is important, and I recommend everybody do it. They are very fast because there's no user interface to go through. They can basically run as fast as your APIs can respond with data. So they are pretty fast. You can gate your builds around them. And they're going to catch quite a few more issues. And they're going to be testing some integration in basically accessing APIs from outside of your application. Then you get to automation, which is going to be slower because you're going through a UI. And that can take a while, so I recommend, which I'll mention down here, breaking your test up into a fast run and a slower deep dive run. And the key to this process is catching issues very early on. So if an issue happens here or here, you may have saved hours of manual testing effort down here. You found a critical issue in the automation, go back to the developer, say, please fix this. They run through this again. This all, even though automation is slow, it's much, much faster than manual testing. So if a manual tester, if you didn't have the second and third layer here, and a manual tester goes through their test cases, runs through the application, and finds a critical issue after hours of testing, then it's possible that the developer fixes it, and they have to start this testing cycle all over again, depending on the bug that happened. And you can lose hours of work on that. So if you catch those issues, the easier to find issues very early on, you're going to save your manual testers a whole lot of time. You're going to save your team a whole lot of time. So let's go down into the conceptualization here. There's a good idea to delineate between smoke tests and a deep dive set of tests, which is all the tests. Smoke tests, you're going to make them as fast as possible, and they're going to cover generally the happy path, the critical features. And in doing so, you hopefully have made them very fast. That's the key here. So you want this fast set of tests to be run somewhere up here as part of a gated build maybe, if you're confident enough in these tests. They can run very fast. You can catch the most critical bugs that are also probably the ones that would cause you to have to do a reset on everything and start the process over, retest. And then you can also have this deep dive set of tests that you could run periodically. Every X number of hours, you can trigger it after a build from a development environment up to a staging environment, or you can also just run it ad hoc. That's generally what I would do. So the final point that I want to mention is the evolution of the role of automation engineers. It's no longer just UI testing. Years ago, it was just that. But these days, automation engineers also do a lot of API testing. They do a lot of DevOps work. So it's a good idea for your automation engineers, if they don't already know how, to get them to learn API testing. It's much simpler, in my opinion, than UI automation testing. So if they already know that, they'll be able to pick up API tests very quickly, and that'll be very helpful for your organization, having somebody to create those for you as well. And then once they understand these things, get them into Bash or PowerShell or any shell, and get them familiar with that. And then also put them into the DevOps sphere, get them setting up a CI process, Jenkins, Bamboo, Azure pipelines, or DevOps now, whatever works, and get them into that sphere. You're going to have most automation engineer roles doing some DevOps as well now. So that is essentially the critical role that QA automation is playing in the software development lifecycle.